Okay, very big welcome everyone here tonight to the regular meeting of Pennine Ham, and to a big welcome as well to those who are watching us on YouTube and those who watch the video later in the week. Tonight, I'm really pleased to welcome Jonathan Hare G1EXG, who's going to give us a talk about an article he had published. I know he wrote it a long time ago, but had published in September last year in Practical Wireless on a 2-element end-fed array for 10 meters. And as soon as I read the article, I remembered as well that our member Bob N4XAT out there in New Jersey had some while ago sent me an email saying, have you seen Jonathan Hare's website and his QRZ page? He's got lots of fantastic talks that he gives. He would be a great person to invite. And as soon as I saw the article in Practical Wireless and I started penning the email to Jonathan, I immediately remembered Bob's email to me of a few weeks or months ago. So we've managed to get you, Jonathan. Your website and your QRZ page is full of fantastic information and links to your website and your YouTube page. So it's really welcome to see someone who is, you know, a practicing scientist. We've got a few retired ones in this room, I can tell you, but we've got someone who is still doing that for a living, but also, you know, producing fantastic videos and presentations and talks like the one tonight. What particularly got me hooked on the article in Practical Wireless was that what you were describing the build of was a simple antenna, not too big because it's for 10 meters. And we're right in the middle of solar cycle 25, and 10 meters has been open an awful lot. And this looked to me like a little fun project that lots of people in the room here might like to try building. So Jonathan, I'm going to hand the microphone over to you.
Thank you very much. Let me just, well, as an introduction, yes, thank you very, very much for that. And thank you for inviting me. So I was licensed in '84 as a schoolboy, as a lot of us were. And I've been a scientist and science communicator, self-employed scientist and science communicator really all my life. So I mainly do science workshops with kids, but I do adults as well. And I was involved with some research at Sussex University as well. So I still build scientific equipment, and I used to give about 100 workshops a year all around Britain and abroad sometimes. But I've loved amateur radio as well since I was a child. I really like making things. I mean, that's the draw for me. And amateur radio is just one of those wonderful hobbies where there's so much you can make. So let me put my presentation up. And I need to share it first, don't I? Let's get
Jonathan, just while you're doing that.
Yeah.
When Jonathan and I talked yesterday, he said that he does like to try and get a bit of interaction while he's talking. So there might be a few moments where he says, I'll just open it if anyone's got any questions on anything I've said so far. So when that happens, obviously you can do. So just either use on the reaction tab at the bottom of your screen, you will see there a little thing for doing various things. One of them is to raise your hand. So it'd be a big help to me if you could do that at that point, or just wave frantically, or unmute yourself and say, I've got a question. Jonathan, back to you. Sorry.
Yeah, no, do, because there's nothing worse than, you know, listening to a speaker and you're lost, or you don't understand, or I've said something strange and you're wondering about what I've said. So yeah, if something doesn't make sense, then do please say something. So hopefully you can see that. Is that right, Nick? You can see that?
Absolutely fine. Yeah.
Brilliant. Now, can you see my mouse, by the way?
Yes.
Okay.
Very small, but it is there.
No, that's all right. I'm just interested. Right. Thank you very much. So I want to talk to you about this end-fire array, and also its brother and sister, which are really the HB9CV and the ZL Special, and also the cousin, which is the turnstile antenna. So I'm not going to talk massively about these other antennas, but they're all related. And what's interesting about all these antennas is that they're all examples of 2-element arrays where each element is driven. So unlike, say, a 2-element Yagi, where you've got a dipole that's driven and one passive reflector, in these antennas, you know, both elements are driven. So in principle, you've got a lot of control of what the antenna will do. And the reason why I'm bringing in the turnstile antenna, which doesn't seem related at all, is that I learned quite a lot from the matching on that and the phasing. So I won't talk a lot about these antennas, but they're sort of all related. They're quite interesting. So in September last year, Practical Wireless published an article by me on this end-fire array. So what it is basically is it's two half-wave verticals that are spaced an eighth wave apart and fed out of phase. So I'll go into much more detail as we go into the talk. But essentially, it's a vertical antenna, and it's a beam antenna. And you can download a copy of this from my website. Practical Wireless are very kind. They let me, when they publish, they say, please don't put it on your website for a couple of months. But after a few months, you're welcome to put the PDF up. So if you get Practical Wireless, you can read the article from September last year, or you can go onto my website, which if you just put Creative Science in Google, it will come up. If you go to the publications, you can download a copy of the PDF. So thank you to Practical Wireless for that. They're very good, I think. The idea is not mine. I've just kind of made a version of it. I first came across this wonderful antenna in the wonderful little publication by Practical Wireless called Out of Thin Air. And in that little booklet, which is a lovely book, you can probably get that on one of the secondhand internet bookshops. There's an article by Fred Judd on compact 2-meter beam antennas, and there's loads of really nice things to make in that article. And one of them is this curious thing called an end-fire array. So on the left here, you can see the basic idea. He's made up a little wooden structure out of dowels and out of wires. I don't know whether you can see with the mouse, it doesn't matter too much, but you've got a half-wave vertical here. You've got a half-wave vertical 30 centimeters away, a matching arrangement, and it's fed in the center. So you've got this rather interesting antenna. It's basically a half-wave vertical, but two of them. And it's a bi-directional pattern. It's fed in the middle, so it has to be symmetrical. So it's a bi-directional pattern. And so it's a sort of thing, if you live in a flat or something, is quite a nice little antenna for 2 meters. And no radio is required, by the way. And this goes back, it's probably 100 years old or maybe more. This I found in my book collection, the 1948 ARRL handbook. And in that handbook, I found 3 versions of this antenna. So if you go over to the left here, you can see this is basically the same thing scaled up for HF. So you've got these half-wave wires, 1/8 wave apart, with some weights to hold the thing and a pivot at the top. There's another version here that can hang from a wire. And here there's an interesting one. There's a sort of horizontal, more compact version, really, which is folded round. So it's quite an old antenna. And it's a balanced antenna. I really love balanced antennas, and we'll come on to that in a minute. And phased arrays, of course, we use all the time. I mean, one of my favorite antennas on 2 meters is a 2x5 spaced 1 wavelength apart. And I can make these antennas. I think the last version I made, each antenna was 250 grams. So the whole thing's incredibly light. And because there are only 5 elements, it's got a very, you can turn it very easily, quite a light antenna. And this particular pair of antennas is fed a wavelength apart. But quite frankly, for HF, a wavelength, even on 10 meters, is quite a long way. You know, it's filling up your garden. And so what's usually people do with the collinear arrays, where you're phasing up more than one aerial, is to have them half-wave apart. So for example, something like this, where you have a whole range of antennas, half-wave verticals, space them half-wave apart, and then you have a matching arrangement to make sure that they're phased up correctly. And you can make a beam antenna like this. So in principle, if you have a half-wave spacing, it's a wavelength or a half-wave is sort of the ideal spacing. And if you can apply power to both these verticals, then you might think initially that one's going to destructively interfere with the other. But of course, by the time it takes this wave to go across to the other element, this wave has moved on, and so it arrives in phase. So you can basically add the signals together if you have half-wave verticals spaced half wavelength apart. Now, as you bring them together, of course, you're going to have problems because they're going to destructively interfere. And once you get them a bit closer, like an eighth, you'd think that was really not very good at all. But we'll come on to why the eighth wave spacing in the end-fire array works in just a second. Now, of course, if you take this to the extreme case, if you bring the wires really close together, you basically got a twin feeder where you don't want any radiation. You want the power to go through without being radiated away. Now, the trick with the end-fire array is that you mount them at an eighth wave apart, which could be a disaster, but you feed them out of phase. So electrically, it looks as though that the spacing is greater. It looks more like a half wave spacing in terms of electrically. So an eighth wave is 45 degrees. So if you mount the antennas an eighth wave apart, but you phase them, you apply the power out of phase to each other, then it's effectively 135 degrees out of phase. So you can make a much more compact antenna than you would if it was a half wave apart, but with quite a good response. This is the 2-meter version. And I've got it beside me, which I can show you later if you want to see any details. So this one's I made out of Perspex. I make a lot of stuff for science museums. And so I use Perspex quite a lot. And I've grown to love the material in some ways. But it's quite a good electrical insulator. Because you're holding these antennas at the voltage maximum, you want some really good insulators. I mean, if you've got enough space, you could hold them in the middle, of course, which would be better, really. But there's some advantages of mounting the whole thing at one end, because obviously the whole thing is that much higher where you've got it mounted. So this is a 2-meter version. I made a 4-meter version, and this is the 10-meter version on the side of the house. So I made at least 3 different versions. They all seem to work really well, and I really, really love this antenna. It's one of my favorite antennas. So if we go back to the practical wireless details, you've got your 2 half-wave verticals spaced an eighth wave apart. So at 2 meters, a 2-meter band, they're about a 1 meter long, each of the half waves, and the spacing is about 30 centimeters. And then you've got a little open wire feeder or twin feeder arrangement here. And if you look carefully, you'll see that, in fact, I've got a better picture here, but one of the half waves is connected to the bottom, if you like, of this open wire feeder array. And on the other side, it's connected to the top. And either way, the other end is left open. So when you apply power in the middle, you're effectively providing power out of phase to the 2 elements, the 180 degrees out of phase. And I don't know whether you can see this, but basically it's got a profile of the normal dipole and then the sort of radiation pattern you'd expect from this end-fire array. And they claim sort of 4 dB, not 40, 4 dB gain roughly for this sort of antenna. So now the interesting thing is if you feed it in the middle, you've got the end-fire array with this bidirectional pattern, like a figure of 8. But if you basically feed it at one end, you basically got the HB9CV or the ZL special. So in principle, if you had an HF version of this and you didn't want to have a rotator on it, you could in principle have 3 feed lines with relays and feed it in the middle to get a bidirectional pattern and then switch from one end to the other. You could beam in the direction that the feed point is. So for example, if you've got the feed point on the right here, it's beaming to the right. If you switch over to the feed point on the left, it will beam to the left. So it's quite an interesting antenna. So let's go to the turnstile antenna. The reason, the turnstile antenna is 2 dipoles set up in a cross. And there's a phasing harness here, a quarter wave phasing harness, which effectively makes a circular polarized antenna. So if you imagine, it's a bit like one of those water sprays you have in your garden. You put them out in the garden and the pressure makes it spin round and it produces this sort of spiral of water. Then the phasing on this antenna is such that it will produce the circularly polarized wave, which is flying off upward effectively. But you can use this as a horizontal antenna. And in fact, in the 80s, I had a friend, G0CIU, who was at Stafford Polytechnic. And in the holidays, we used to come back to Worthing where we lived. But when he'd go off to university, I would work him on 2 meters all the way up to Stafford. And so I had a 2x5 and about 25 watts. So I point this north from Worthing, and we arranged for a little turnstile antenna on his car. And we could work each other all the way up the country, basically, on 2 meters. It was really nice. He had a bit more power in the car, but it worked really well. So what I built in this time in the 80s, so this is on the right is the cross dipoles. And you feed power up to the first dipole here, and then you have a matching arrangement which feeds power to the second dipole. So I rather strangely sort of flattened it out here on the left so you can see what's going on. You've got some kind of a twin feeder going up to the first dipole, and then you've got a quarter wave line which goes to the second dipole. But of course, in real life, they're crossed. I hope that makes sense. And then I had a halfway matching section here to match it all to 50 ohms. And it worked. But I realized straight away there was something a bit odd about it. And it took me years to work out what was going on until I knew a bit more about antennas. Because the trouble is it's making sure that the impedances are all correct along the whole length of this antenna. And I won't go into details, but what happened is when I had it on the antenna analyzer, I could certainly get a really good SWR on this. But when I touched the ends of dipole 2, the SWR will go flying off, as you'd expect. But when I touched the ends of dipole 1, it didn't really make much difference to the SWR at all. And I think what was happening was that the matching section was matching this first dipole perfectly. But there was such a mismatch on this line that it wasn't really even in circuit. And so although it gave a great SWR, actually this second one wasn't really working. And the reason why it could work, Steve, of course, because he was north, I think I was just getting him on the one dipole 2, and dipole 1 wasn't really ever working at all. So the reason why I'm telling you this is because actually, if you want to make this to work properly, you've got to make sure that this little quarter wave line is properly matched. Everything's properly matched. Otherwise, you get great power transfer to this first dipole, but you don't get much power transfer to the second dipole. And the way to overcome that is the various different techniques. People use 75 ohm for the phasing line here. So the dipole's roughly 75 ohm. You've got a 75 ohm line in parallel with another 75 ohm dipole. That gives you about 40 ohms. And then you put up with the poor SWR, well, it's not too poor if everything's good. You can use Q sections and things like that. What I've done just recently, I decided to make the same thing but out of folded dipoles, because the folded dipole is 300 ohm. Then I can use 300 ohm slotted feeder for the quarter wave. You've got a 300 ohm, another second dipole, a 300 ohm here. And so you know everything's at 300 ohm. And so effectively what should happen is that at the center here where the two join, you're going to get maybe 150 ohms here, and you can match that with the half wave. Then when you build one of these and you touch the end of the dipoles, the SWR goes mad, whichever dipole you touch at the end, which is what you'd expect, of course, because the ends of the dipoles are the high voltage ends. If you touch that with your hand, it should make a big difference to the SWR, and it does. So I made one of these last year. Primarily, there's a 2 meter one here, and there's a 77 one above. And I was thinking of using it for the satellites, which I haven't got around to. It's one of these new projects. I'll probably need a preamp to get that to work, to be honest, anyway. So what I learned from the turnstile is that matching section is important, because if that's not right, it's not going to work properly. So for example, if you go back to the end fire, because this is fed in the center, it's a lot easier to get this to work, I think. But if you feed it at one end, like the HB9CV, then it's only going to work properly if the matching section's right. So with the HB9CV, you usually have 2 half-wave elements spaced an 1/8 wave apart. And you have this little matching arrangement around here to try and feed the back one out of phase with the front one. And you get, if it works, you get this beautiful front to back ratio, this cardioid pattern, and virtually really, really good front to back ratio. So for example, one of my friends in Brighton, his neighbor's got these new LED lights, and it just wipes out 2 meters. And it's to the point where you can't even use the band. So I've suggested you get an HB9CV, a good one, and don't worry about where it's pointing, but just arrange for the null to be pointing towards his neighbor's kitchen, you know, where the lights are. And it might help because there's this really beautiful null here, which you probably wouldn't get on a 2-element Yagi. The often on the HB9CV, one element is longer than the other, you know, but you don't need to be. Just as in the end-fire array, you can have them both are half-wave elements, and it's just the phasing that produces the directionality. But they tend to make the reflector slightly bigger and the director slightly smaller, I think, to give it a little bit of a bigger bandwidth. So if your phasing harness is not right, I think what's really happening is that this bit of the phasing harness probably just disappears. There's no real power transfer around here. And really all you've got is a standard Yagi that you've got a delta match, what's it called? A gamma match and a capacitor. And you haven't really got an HB9CV. So the way round that, of course, is the ZL special, because the ZL special uses folded dipoles. And so these are 300 ohms, this is 300 ohms, and you can use a 300 ohm matching section. And you know everything is going to be matched. And that's why in some ways the ZL special is better than the HB9CV. I know quite a few people who've had HB9CVs on 4 meters and not had very good performance with them. And I'm sure it's down to this problem of getting the matching section right. And it's not easy to measure that. So that's why the sort of the ZL special, I think, is a nicer kind of design. And in fact, funny enough, in Fred Judd's article, he talks about the ZL special, and there's a really nice design for a 2-meter one, and even a 5-element one. This is what I use at home. This is my 5-element ZL special, and you can see the folded elements here. I've used aluminium bonsai wire. This is stuff they use for bonsai trees, and it's like 4mm aluminium wire, and you can bend it into these loops, and it produces a really beautiful antenna. It's very, very short. It's got a nice gain, and it's wide band, so it ticks all the boxes. And this is just over 1 meter long for a 5LE Yagi. It's really, really super antenna. Good gain, broad SWR, and really good. So just to recap them, because I've sort of gone off topic a little bit. The end-fire array is 2 half waves spaced an 1/8 wave apart, but with the matching section here, the little phasing arrangement, you feed the dipoles out of phase. And you need a phasing line. And if you want to, you can follow Fred Judd's suggestion of using a little matching thing and using coax. And I did try this, and it worked quite well. But we'll come on to that in just a sec. Now, for the 10-meter version of the antenna, I decided to use 5-meter long telescopic rods. And I was amazed to find that you can get these 5-meter long stainless steel telescopic antennas. And if you buy them from the reputable dealers, they're quite expensive. But as Nick said, you can get them on AliExpress for half this price or even 1/3 of the price. Take care with them, because obviously they're 5 meters, so they're almost 18 foot long. There's a lot of leverage on these things. So when you compact them down, I think I talked to Nick the other day about this. You know, if you're being 3 hours out on the hill and you're cold, you're kind of rushing to get home. But you have to be a bit careful with these, because it's very easy to bend them. Also, there are little copper shims between each of the sections, and it's easy to pull them out. And of course, once you pull them out, that's it. It's really, really difficult to get them to work again. So what I do with these, I never quite pack them up completely. I always leave a sort of centimeter between each section, or half a centimeter, just so that when you pull them out, they don't stick. And there's that horrible moment where you don't know quite how much pressure to pull them open. So they're lovely things. They're stainless steel, and but you just got to be a little bit careful with them. So in my arrangement for the 10-meter antenna, I built this wooden frame. On 10 meters, the antennas, of course, for 10-meter band, they're half wave. So they're about 5 meter long, each half wave. They're spaced about 1.2 meters apart. So I built a little wooden frame, and this is on the side of the house. This, believe it or not, is a chopping board. Not from my kitchen, but in Brighton, they've got this nice thing where people leave stuff outside. Rather than chucking it in the bin, they leave it outside for other people to use. And I found a stack of 5 of these chopping boards that someone had left out. And they're perfect because they're really good insulators and they're really strong. So I used this as the center and put some U-bolts on there. And then I 3D printed some insulators. So for making the 4-meter version, I literally just scaled everything by 2. And for the 10-meter version, I just scaled up the 2-meter version by 5. Now, these are broadband antenna, so you don't need to worry too much about the dimensions. And if, to be honest with you, if you feed it in the middle, you don't even have to worry too much about the phasing network. But the 4-meter version, you can see I've used crop clips here. You just go along with the crop clips until the SWR starts to drop, and then you move this little shorting bar, and by a process of sort of iteration, you can get the SWR down, and then take off the crop clips and solder it on, and then paint it with some sealant, and you've got a really nice antenna for 4 meters. I wouldn't leave the I put the exclamation mark there because I wouldn't leave the crop clips there. They're just for testing out. All the details are in my article, so I won't really go into the actual lengths here. I did try using a phasing network and coax, and it works. But as this is such a broadband antenna, it's a shame to use the coax really, because it does limit the bandwidth that you can get, the sort of 2-to-1 SWR bandwidth. So I tried it with a 1-to-1 balun, and then I also tried it with a 4-to-1 balun and found a different place on the matching network, and it works. But with the 1-to-1, it was a sort of 300 kilohertz bandwidth, and on the 4-to-1, I got a double that roughly. But the real joy came with using the balance feeder, because it is a wideband antenna, and these things are very forgiving because the 2 antennas are basically singing together. There's a coupling between them, and it's a very, very wide band forgiving antenna. So it's a very, very nice thing. So if you use coax, you don't really get the full benefit. So I built a little balanced ATU. There's a picture of it here. Managed to get some silver-plated copper wire. You don't need it, but I used it. I had some, and these are just capacitors I happened to have. So this is a dual gang capacitor on the right here, and a single gang here. I tend to put these in an ultrasonic bath and clean them up extensively before I use them, which you can see I've done on the left hand here one, and it works absolutely beautifully. The insulators I used, I love my 3D printer, so I happen to print some 3D printed insulators, but you don't, you could use whatever proper insulators basically. So there's 2 types. There's one here that's got a little cup to take the bottom where the stud is at the bottom of the telescopic rod, which goes onto the phasing harness, and this one here just holds it in place. So this is the antenna on the side of the house. I can get up on, I've got a roof above my office here, and I can get up on this side roof, and I've got a little arrangement here. So this is one of the half waves, not extended. This is the other, and we've got the phasing harness here and fed in the middle. And I've got 300 ohm cable. It's fed in the middle. I'm just going to have a drink. This is another view. Sorry about the rather disgusting north-facing wall. And this is a few views of the antenna. So basically, if you think of the antennas are mainly radiating sort of halfway up, it's well above the roof line. And in fact, I actually built a little slide mount so that I can put it down and raise all the telescopic antennas. But when it's all raised, I can then raise it up another 1.5 meters to the top here and get it up as high as possible. Right. So I'm using my voice a bit. So what about some results? Well, last year and the year before, Colin, G3ZAF, who's got a Ukrainian wife, decided to set up a regular net with some of the Ukrainian guys, just really to give them something nice to talk about. Vlad, US7AGN, has written a book actually about his experience in Kyiv, and his amateur radio really kept him going. And he was living in a corridor for 2 years, basically, because they didn't know whether the windows were going to get blown out by bombs. So amateur radio was really important for them, not as obviously as a political thing, but just having something nice to talk about that we all have in common. So I had quite a few nets with Colin and Vlad, US7IGN, and well, I was able to really test out this antenna. And Colin's got a hex beam, and so about 100 watts, which is what I was running. And I was getting similar sort of signals. He's got a horizontal hex beam. I was using the vertical array, and we were getting similar sort of signals in with moment-to-moment variations, but similar sort of results. I've got a friend in Florida, M0TJK Roger has got a place in Florida, so I've been talking to him and comparing it with the University of Sussex Radio Club as well. They've got a 3-element tri-bander. So all these things I could have on at once and compare them all. So the results, as you'd expect, I'm getting better results than with a vertical dipole. Similar results to G3ZAF's hex beam. His hex beam isn't very high. It's probably only about 20 foot above the ground, where the center of my antenna probably was a little bit more than that. And the University of Sussex Club Station, which has got a 3-element tri-bander, it's cut for the CW end of the band, so it's not so good for sideband, but I was getting, I think the 3-element was better, without a doubt, although they're horizontal, but sometimes it does make a difference. If you monitor both together, you see there's moment-to-moment variation. Sometimes the end fire being vertical will get a better signal, and sometimes the horizontal beam at Sussex, which is just down the road, will get a better signal. It sort of varied as the propagation was changing. Yeah. The nice thing about using the balance feeder is that because it's a broadband antenna, it works on other bands, and it certainly works pretty well on 15 and 12, even works on 6 meters. And it will work on 20 meters as well. It's obviously not very good, but it's not bad. I mean, certainly it loads up fine, and it will get me on the air. So in some respects, it's a very versatile little antenna for the higher frequency bands. Just before I end, it's a year now. It's been up over a year, and on a north-facing wall, and you can see that the insulators have gone a bit grotty. So I was a bit worried that because it's holding the elements at the voltage maxima, these insulators need to be good. So I actually changed them all over last week, and I didn't notice any difference. I did some checks with the University of Sussex station and with local stations beforehand, changed it over, and there was no noticeable difference. So I think actually the insulators were working. But just recently I have put an extra perspex sheet here, just so that when it's raining, because obviously this wood is going to start to conduct when it's wet. So now I think with the combination of the little plastic insulators here and the perspex, I probably got a better antenna if this whole thing gets wet. So I didn't notice any difference with this mod, which is a good sign, I think, but I feel better about it now. A few other things. I stupidly used the steel rather than the stainless steel bolt on the end of the the telescopic rod, which was a mistake because you can see it's all rusted up. So that will be a good thing, and probably it's worth putting a load of gunk over here or paint it with liquid tape or something, because there's obviously the difference in metals here. It's reacted, and you know, this one's basically useless. I can't get it off now, so I had to change it. So if you want to find the article, please find my website. If you put Creative Science in Google, it will come up with my website, and then you can go on the publications and you can download the article. I'd like to thank Vlad and Colin and Roger and Graham and also G3XTT from Practical Wireless for this whole story of making this antenna. It's been really, really good. Yes, so I will leave that for the moment and wonder if there's any questions. Did that make any sense, anyone? Hopefully you could hear me.
Yeah.
Nick.
Yeah, that was absolutely fine, Jonathan. I heard every bit, and it made a lot of sense. Just before I forget, some element clamps are sold by a guy in Colchester in Essex. If you Google search aerial parts of Colchester, and he sells all kinds of parts for making antennas and bits of aluminium, and he sells 2 sizes of element clamps.
Insulating clamps.
Insulating clamps, exactly the same. So let me just show you quickly, and then we'll open it up. But these are the clamps, and they're only something like £1 10p each. And he sells them in 2 sizes: one to take a 1/4 inch tube, and one to take up to 1.5 inches.
Yeah,
and they would probably do the job if you haven't got access to plastic printer, but that's definitely an option, and a very cheap one as well.
Yeah, or nick the chopping board from the kitchen. That will do quite well.
Yes, chopping boards feature highly in antenna building, don't they?
But they're very strong and they're good insulators. Yeah.
Yeah, and Perspex is reasonably expensive to buy. So the chopping boards are, go into one of these cheap shops, B&M and Home Bargains and so on, and pick yourself up a chopping board for £1. It's considerably less than buying the Perspex.
When I because I said I'd made quite a bit of stuff for museums, the first job I ever did with Perspex, I had a meter square sheet of Perspex. It's like £100, and I put a drill in the middle and it shattered. And I thought, oh my God, I'm never going to be able to work with this material. And then someone told me, keep a set of old blunt drills. Because the last thing you want to do is with this Perspex is put a sharp drill in it, because it just splits it. So if you've got to keep a set of old drill bits that are slightly blunt, they're perfect for Perspex. And I never had a problem again, but it was a bit of a shock. But yeah, I've got lots of offcuts of Perspex, but it's there are lots of other things you can use, I think.
Yeah, the Perspex looks the best, to be fair, but it is pricey.
And it's really strong. I mean, if it's thick,
Yeah.
I think I was using 10mm, 8mm thick Perspex. It's pretty strong stuff, when it's quite thick.
Right, well, we've got a room full of people here who love antennas. Lots of them do. So, who wants to go first with a question or comment to Phil about his fascinating presentation this evening? Yes, Keith. I've got Keith here. Yeah, go on, Keith.
Just a comment about the turnstile antenna. I've been doing modeling of turnstiles on 50 megahertz using a 22mm tube. And a simple dipole, gives a bandwidth of about, 2.8 megs. This is for between the 1.5 SWR 1.5 points. But if you put the second one in with its matching stub, it goes up to over 10 megs.
Oh.
So interestingly, if you look at it on a Smith diagram, the two curves are like mirror images of one another, and they sort of cancel out, which is an interesting oddity. And I'm just wondering if you experience anything like that with your work with phasing stubs.
Well, I mean, one of the explanations for this, why the folded dipole has got a slightly bigger bandwidth than a normal dipole, is that they kind of look like quarter wave stubs. And so they sort of cancel the bit of reactance you get when you make it smaller or bigger. So it sort of broadens the response. And I don't know whether there's something like that going on. But my reason for mentioning them was really that I think if you don't get the impedances right to that second one, you don't get much power transfer down to it, and it's really just working like a dipole. And so you have to, and it's not always obvious if you make your own phasing networks or whatever. Well, you probably know what the quarter wave impedance is because you can work that out, but how you tap on to the next dipole, the second dipole, I had a little delta match, which is probably not the right way of doing it. So no, I don't know much more about it, but it's very interesting. I mean, phased arrays are very forgiving. They seem to be quite broadband. These big collinear arrays they use for EME kind of work, where you've got dozens and dozens of dipoles phased together, working together. They seem to be very, very forgiving antennas, very nice antennas, I think. So it wouldn't surprise me that the turnstile has got a little bit of that as well. Does that answer your question at all or help?
Yeah, and just a further comment about turnstiles. The work started off, I was looking at interlocking loops. Because with delta loops, for instance, you can actually, with the geometry, you can change the impedance. And what I did was designed a loop for 200 ohm loops interlocked.
Yep.
You put in 100 ohm feeder with two coaxes working parallel.
Yep.
And of course, that comes down to 50 ohms. You don't need any more feeders.
Yeah. And have you tried that in practice?
I haven't tried it yet.
I know because if you think about a quad, it's about 100 ohms. So you think if you put two quads together, it will be roughly 50. But I know that there is an interaction. You get some reactance.
Yeah.
And it doesn't give a very good match. and I built one of these for 2 meters, and you know, it didn't give a perfect match. But when I brought it near to the garage door to give a little bit of counteract the reactance, the SWR went right down, and of course, so often with the you know, the sort of things. Got one here for 23 cents. Oh, you can't really see it. Yeah, so you've got basically 2 quads in the center, the joint in the center. But you really need this the reflector to get the STR down. I think it just gets rid of a bit of the reactance having the reflector there, and of course it adds a little bit more gain as well.
Sure.
So maybe you might still have to play around with getting rid of some of the reactance between the two, but it might not be much, in which case, you know, especially as they're 90 degrees. So yeah, interesting, really. I mean, the thing about aerials are just, you can play so much with aerials, can't you? And it's such a wonderful part of the hobby because you can make aerials out of wires and things. You don't need a lot of money.
Absolutely.
Exactly. Yeah.
One of the reasons why I like the end fire away, because if you look at that image from 1948 or whatever it was, you know, they were just wires strung up on a wooden, you know, you don't have to have telescopic rods, which are expensive. You could just have wires, you know. It's a really, really nice experimental antenna.
Yeah.
I've got Jeff, OL8NT.
Hi. Okay. Good evening, Jonathan. Thank you very much for this. This was a good extra addition to your article in Practical Wireless. It gives some good background, I think.
Thank you.
Very interesting. And this afternoon, I also surfed onto your web pages and your QRZ page, and really interesting. I would recommend everyone to do that. There is a mine of wealth of information, really interesting. I discovered lately that there is now a 25 feet telescopic antenna, so that might open the possibilities for maybe a 15-meter version of what you have developed. And I'm just wondering, living in an apartment, if one element of your end fire system would work, probably will do, but this will probably need another feeding arrangement. I don't know if that with the 300, although that could work, of course, but just your ideas on that, Jonathan.
Yeah, well, the nice thing about the end fire array is that you don't need any radials, right? Because you're feeding it at the end. Now, I know when you run a single one, you should have a little counterpoise.
Okay.
But I have actually ran the antenna with just one of them up, and it does work. But I haven't checked the polarized, you know, the radiation pattern. But one assumes that with just a single one, you get it'd be like a vertical. I don't know. They'd be a bit more lossy, of course, because of all the other stuff in the system. But I think it's an interesting idea. I think what you're saying about the really long telescopic rods is this antenna works pretty well on 15. So if you had the really long ones, perhaps you could even develop something for 40 meters, you see.
Yeah.
Like a 2-element beam on 40 meters, that's quite a nice.
Yeah.
And especially on a flat, if you've got a balcony, this is a really nice antenna to put on a balcony.
Yeah.
One thing I didn't say, one of the reasons why I built this antenna is because I live in a terrace of 3 houses, so that we're all very close. And my neighbor, Jeff, is an audiophile, so he's got some really high-end audio equipment, but there's no filtering in it at all.
Oh, Jesus.
So even 10 watts comes through. So one of the reasons I wanted to work 10 A, because you can work around the world on low power.
True,
and B, with the 2-element array, you see, I've arranged it so there's very little power going in his direction. Now, I know it's difficult because the polar pattern is the far field, and the bidirectional pattern is probably only really many wavelengths away. So he's very close. But I did think, you know, one of the things about being in a flat, I don't know if you have this, but you've got neighbors that are very close. So you've got a lot of noise sources. So having a directional antenna is a really nice thing, especially there's quite a sharp null on this antenna. And so you've got the option A, not to put power in your neighbor's equipment, which is good, and B, perhaps null out the noise from your neighbor's electrics as well. So that's another added bit about having this directionality, which I think from a flat dweller's point of view is a really, really nice idea.
Thank you very much. Very interesting.
Thank you.
You've got Jeff thinking there.
Yeah, again.
Oh, the other thing I didn't mention is because it's bidirectional, you only need 90-degree change.
Yeah,
you
true.
need 360.
Yeah.
So that's kind
Yeah.
of interesting as well. You don't need such a big, you could almost do that by hand or some hand mechanism.
Yeah. Brilliant. Good.
And it's
Thank you.
100 years old.
Yeah.
Thank you, Jeff. Gavin.
Thank you, Nick. Jonathan.
Yeah.
You mentioned good show, by the way. Good presentation.
Thank you.
Thank you. Jonathan, you mentioned that the 5-element, the beam array was like the best performance. Did you ever try a 6-element, say a 7-8 element beam? And also, what materials did you use to get it down to such a low weight?
So for many years, I've used a 5LE on 2 meters, either in singly or pairs. So I'm really used to using an old ARLL design 5LE. It's my standard benchmark. So it's a really lovely antenna because it works really well. It's not super high gain, but it works. And the ZL special is shorter than that. And of course, it's a bit more complicated because you've got this double folded dipole with the twisted feeder array. But it's higher gain than the ARRL 5LE. It's light, it's smaller, and it's very compact, and it's pretty broadband as well. So it ticks all the boxes. If you read the article, the original, let's see if I can get that up again. My mouse has gone to sleep. Share. Let's go back to my PowerPoint and just quickly go back to that. Got to try and find it now. I will share this in a minute. I know. Oh, it is showing. Good. Where was it? Oh, here it is. So, Nick, is this coming through?
Yeah, it is absolutely fine. Yep. Yeah.
So down here, you can see this is his design for the ZL Special. So it's 2 folded dipoles. He's made one slightly larger than the other, so he broadens it out a bit. You need a little capacitor here to match it to 50 ohms. And there's a bazooka ballon here, but you can probably do without that, but I used it anyway. So this doesn't give any impedance transformation. It's just a 1-to-1. But when you add another element and another element and another element, you need less and less capacitance. And when you get to about 5 elements, it almost matches perfectly. But when you try 6, you're going to have the problem. It's got too much reactance the other way, presumably it's a bit capacitive. So you can't use the trimmer anymore. So I only ever used the 5LE. There's details of this on my website, actually. I wrote this up on one of the pages. It's a really terrific little antenna because it's very compact. And I just used a bit of Dow, was it Ramin, I think this is called. And these are aluminium welding rods. These are a glass fiber tube, which I cut with a Dremel, and then fed the aluminium bonsai tree wire through there. And there's a little chocolate block connector in here, which join them all up. So this is, I think, 4mm aluminium wire, and it's been up for about 10 years. And apart from the squirrels nibbling the coax at one point, it's worked constantly really, really well. And it's light enough to put up right on the top of my mast. So I haven't done any other, I haven't done any proper measurements as such, but it is a really, really nice short, wide band, quite high gain, compact little 2-meter antenna. It's really, really good.
I think because it's with portable ops in mind. So when you announced the weights, that's what attracted me and had me ask the question, because for a small antenna with the sort of results you were getting, that was fantastic. Thank you for answering.
Well, I didn't actually. Now let me go back to this. Where were we going? See this one. Oh no, sorry. I'm going to have to go up. Excuse me. I'm going to go back at this. Getting lost in my PowerPoint. Where is my? Yeah, let's go. I have to double click on that. So these you can use. It's such a lightweight structure. If you use aluminium welding rods, you can get away with 10mm square tube here. I think I use slightly bigger than that, 12. but these were getting on to 250 grams for this single 5LE. So that's pretty lightweight, you know. And in one of the Ragcom articles, I actually described one using a tube where I put the elements inside the tube. So basically all you have to do is carry the tube, and then you take the elements out and slide them onto the plastic tube, and then there's a little delta match. So that would be quite a good portable antenna. I think 5LE is the benchmark. I mean, to get a decent gain after 5LE, you've got to go to quite a big antenna, haven't you? But you know, on any band, 5 elements is gorgeous to have, you know, and on 2 meters, if you're on a mountain, it might not even be worth the hassle of having a much bigger array unless you're going to do something really spectacular, you know. A 5LE is a really nice antenna.
Thank you, Jonathan.
Yeah, gorgeous.
Brilliant. Thank you very much, Gavin. Anyone else with a question or comment to Jonathan? Speak or forever hold your peace.
Yep.
Yeah, go ahead.
Thanks, Jonathan. Interested that the going back to the materials. Yes, chopping boards, obviously very cheap and cheerful and very reliable. I'm just wondering about the perspex thing. I know it's very brittle. I thought perspex and maybe also your little 3D printed stuff. Maybe it's the UV it's susceptible to, because I know a lot of plastics are not UV stable. So for time, it's the UV that's gonna do for it. I think the traditionally cheap plastics they used to use carbon as a colorant, and it's destabilized it a bit. I don't know if that's your experience.
Yeah, so I've had the 3D printer now since about well, at least I think it's 15 years, and I made a little dipole center quite early on. That's been out in the garden. It hasn't always been up on the mast, but it's been out for about 12, 13 years, and it's looking a bit grumpy, really. But I mean, the PLA, the polylactic acid, which is used a lot in 3D printing, is designed to be biodegradable. So I use the 3D printer for experimental things. I'm not intending to use them for long periods. But you can buy different filaments, and ASA is the same material that's used for gutters, plastic gutters. And so that's much better, got much better UV stability. So if I was going to, I'm not going to sell this sort of thing, but if I was a company making equipment out of 3D printers, I certainly wouldn't use polylactic acid, the standard filament. I'd use something like ASA, or there are other filaments as well, which have much better UV stability. Perspex, yeah, and it can. I mean, I remember going to banks where they had perspex things, and they're all cracked. You know, they have a tendency if they've strained, if they put them in with a bit of strain, you get these little cracks forming on the perspex, and so again, the longevity for perspex is probably not the best material. But I've got loads of it, and I just experiment. So
it's stress cracking, isn't it? It's stress cracking. And yeah, you're not supposed to put any kind of plastic like that under stress. I use this stuff. I use polycarbonate, which is like that is proper UV stable. It can stress crack if you force it. If I had bent it into shape like that and held, it shouldn't do that. You should always have it stress relieved. But perspex, I'm always shied away from since school because I think it's too brittle. It's too, it's going to shatter in the window or something.
No, it depends on the thickness, but I've got some quite thick, like 10 mil is very bomb proof. It's amazing stuff. So it depends a bit, I think, on where it's come from, how it's been treated, and how much stress is in it. You could probably use cross polarized to see how much stress is in it if you have a look at it. But I haven't had any problems at all with any perspex stuff, sort of 8 mil breaking, and this I've got quite a bit of stuff made out of perspex. It's heavy though. I mean, one antenna I've got, which I had funny enough, I had a turnstile antenna where the center was made out of perspex sheet, and it was so heavy to be on the top of the mast. So I drilled massive holes, as many holes as I could to keep the strength, but to take some of the weight away. And again, that wasn't it never broke. I never had a problem with the bug. I mean, if it fell off the mast onto concrete, it would crack. So there's definitely not going to survive that sort of stuff. But
that's the thing. If you have to make it thick to get it strong. That's the and you know, you lose the advantage then, don't you, of the weight advantage compared to using. But yeah, chopping boards are definitely. I would definitely go for a chopping board.
And someone told me, I think there's, I don't know if it's IKEA, but someone sells them pretty cheap. You can buy new ones if you don't want a grubby one, you know, and they're not very expensive. They're certainly a lot cheaper than Perspex.
Yeah, there's some links in the chat already about to get to. We'll all be ordering them in a minute. Thanks very much. Thank you.
Yeah, no, pleasure. I was going to say something else, but yeah, no, I can't remember. I think you did the insulators are important on this antenna when you're holding the aerials at the voltage maximum. You know, I mean, there's no reason why you couldn't have the insulators halfway up at the voltage minimum, and then, you know, the insulators won't be quite so critical. You still have the phasing harness at the bottom.
Yeah, let's say 5 meters is a long way. I've got one of these 5 meter rods here, and
yeah, you couldn't do it with that.
Well, no, but what I've done is when I use this, when I've had a play with it, I made myself a little thing there so I can put some guys on it. Because the wind will do some damage if you do it not properly support it. So that's I guy a single one like that. In a bit of breeze, it's a pain otherwise.
Yeah, no, I think you're right, and yeah, that's right. But with the smaller ones, of course, I mean, this looks like a model, but it's actually the 2 meter one that I built. You can be self-supporting with that. But I mean, whether or not you can if you could throw up a cable onto a big tree and put it up and have it a bit like the, let's just go back to this old lovely, let's go back to this.
The old ARRL one, yeah.
You know, could have something like this, or the one marked A, you know, where you could go portable with that perhaps, and have just some bags full of sand or something, or your lunch to weight it down or something, you know, and you've got yourself a 2 LE beam, and possibly, you know, you can make something like that that almost can roll up into your bag, you know, and go out, and you've got a bit of directionality to get rid of some of the noise or whatever. I think that my key message is to use the balance ATU, you know, I love balanced antennas. Funny enough, if you've just got a second, I've got another article coming out in Practical Wireless, I think next month, I'm not sure. And I can there we go. Let's go. So this is coming out, I think, next month. So I built basically, it's only, it's a 4 meter quad, but I've used some very interesting open wire feeder or twin feeder. And with a balanced ATU, this works all the way from about 40 megs up through the VHF band. So it works on 6 meters, 4 meters. I didn't bother on 2 because it's going to be too lossy, but it certainly is pretty good on, if we ever get the 8 meter band, 6 meters, 4 meters, and for VHF listening. And, you know, and you couldn't do that without the balanced feeder, basically. It's the little balanced ATUs. They're a bit lossy at VHF, but they work, you know, and you've got yourself a universal antenna, which is like really, you know, it's not a high performance antenna, but you can get on all these bands, you know, it's quite if you get it high, that's what I was thinking. I've got a 15 meter fiberglass mast in the backyard. So I want something that's really light that I can get right at the top of that. And I've got height, you know, and height at VHF is everything really, isn't it? You know.
I was going to ask you, Jonathan, before anyone else got any more questions, but about the height of your 2 element array, particularly on 10 meters. I mean, I'm one of those that occasionally uses the vertical dipole and use the flower pot version of it. So you've got one piece of coax and the up to the middle bit, and then the top bit of only the center bit, and fed at the bottom. And I've used that on one of the telescopic carbon fiber or fiberglass poles, and draped it down that, and it works extremely well. So the bottom of that is at the ground. Have you tried your antennas both on the ground and higher up, and what kind of difference does that make at 10 meters, I'm wondering?
Yeah, no, I haven't. I mean, I've got it where it is because it's fixed to the wall, it's stable. and I can retract everything in bad weather. So it's just, I haven't tried it anywhere else. I mean, you could, it almost, if you had a pickup truck or something, you could almost have it going down the side of the truck at the back, couldn't you? And you could park up somewhere and you've got a 2 LE beam. So, but I haven't played around with. The nice thing about the verticals is that, of course, the halfway verticals, the main radiation is halfway up, sort of thing. So it's already a bit high, isn't it? And of course, on my house, it's starting high, because it's basically mounted at the bottom, and so the main bit is above most of it is above the roof space. But no, I haven't tried it lower. I can imagine, going down to the seafront here and beaming across the ocean, it'd probably be quite an interesting antenna.
Yes, Ken, that was made me think about you. Go on.
Have you passed it to me?
I have, yeah.
Oh, thank you, Jonathan. Excellent presentation.
Thank you.
Just a question. Could I just ask you a question? I do make quite a lot of antennas myself, both VHF and HF. Did you consider, and it's a bit of a follow-on from what Nick's just said, did you consider half-wave dipole spaced 0.2 wavelength with a reflector to give it directional quality, and with the lower half of the dipole below house level, what I'm saying, for 10 meters, which would have put the antenna at 8 foot above the house, which doesn't look bad, 8 foot below the house, but the ability to rotate it with a cheap rotator, using probably 4 of these telescopic stainless steel whips. And the other part of this question is, what about the double delta for 2 meters? You know, where they have the delta loops side by side and feed it at the center, at the corner, both corners, to give you a direct. So this is for VHF, not for HF.
You mean like a bow tie antenna?
Well, it's 2 triangles.
Oh.
2 triangles. I'm talking now for VHF, so it's a 2 meter antenna.
Yeah.
So it's about 70 centimeters each side of the triangle, and at the bottom left-hand side of the left one, feeding it, and then at the same time at the bottom of the right-hand side of the left one, and then at the bottom left-hand side of the right one. Again, give it a bit of direction. They were just 2 alternatives. But my main point, because I've been thinking about this recently, is one of the best antennas you can use is a 2-element vertical dipole, but not half wave. I'm thinking of quarter waves. When I say quarter waves, I mean half wave in size, but so that you don't have to have it so high up on the side of the house, because then, you see, we all know in this country, your neighbours will soon take offence if you start putting verticals that are 20 foot above your house. That's why I'm asking. It's just...
Well, yeah, I mean, that's one of the reasons why I use the telescopic rods, because all the antennas I've got here are on telescopic systems, so nothing's up permanently. So I don't think anyone can ever complain. I mean, they might complain, about it. I mean, it's never permanently up. So that's the nice thing about using the telescopic rods, is I can just go up and put them up, when I want to use it, and then take them down afterwards. And then there's nothing to see, really. No one would even know it was there, really. But you're quite right. There's there's so many different options you can try. The nice thing about this array is you don't need any radials, where usually on a quarter wave ground plane antenna, you need, it's obviously an integral part of the whole thing, having the radials. And so you do need to, that makes it a bit more 3-dimensional. You've got an antenna with all the radials, and that looks a little bit more distressing for the neighbors, I guess. Well, this is just a wire going straight up. So I think there's lots of things you could try, certainly with the phasing of quads and delta loops and triangles. I think it's a really, really interesting. The other option is Well, yeah, there's all sorts of noise cancelling you can do with an open feeder as well, I think, which isn't really, that option isn't available with the coax. I mean, the coax is always like a 3-wire thing, isn't it? You've got the inner, the outer, and there's 2 outers really. There's one, the outside can pick up noise, and with the twin feeder you can balance it all. And I really love balanced antennas. They certainly seem less noisy than coax systems. I mean, I think you can get coax systems to work by putting ferrite beads and things around, and you can get rid of the stuff that's picked up on the outside, but the balance feeder gets rid of that problem straight away, and it's really broadband. I mean, I can tune the Enfire array here. I can tune, it's almost 1-to-1 SWI anywhere I want to go with that balanced ATU. It's really, really gorgeous, and it's not ridiculously narrow or wide. It feels like it's working properly, so I'm not sure if I answered your question really, but yeah, I think you could make a version of this. I don't know if you can, whether you can, how much you can bend, because the main radiation is halfway up. You probably can't bend it too much, so you can't probably put this in a loft. I would have thought, not for 10 meters.
No.
You could certainly put a 4-meter one in the loft if you wanted to.
The reason I say, because now you can get these stainless steel poles off eBay for as little as £5 each.
Yeah.
So for £20, you could have yourself a 10-meter band steerable beam.
Oh, do you mean like a Foursquare?
Yes.
Yeah. Oh yeah, that would be interesting, wouldn't it? Absolutely. But they do need a good earth system, don't they?
Well, here's another one. I do a lot of work on the beach. Now, I don't use radials. I use a ground tuning unit.
Yep.
So if I walked away from the main antenna and walked for say 20 meters, I walked back 16 feet and then stuck one of those parasol sun umbrella stands in the sand. Then put another pole in it that wasn't fixed to anything, full length, so it's like a parasitic reflector, and pointed it so that it was behind me and I'm looking out to the sea. I would then have a 2-element, very, very simple wire pole beam with 2 poles, not 4.
Yeah, well, I think when you're on your beach with a bit of salt water, you've got a really nice earthing system there. I would like to take this down onto the beach, and it's not very far away, the beach. It'd be interesting to see what you could work, even at ground level, probably. To answer your question, Nick, about height, you could probably set this up fairly low. I would have thought down by the sea.
I was thinking particularly. I know because Ken's given us talks about it in the club before about his stuff. He goes down in the south of Spain near the salt lagoons and working amazing DX, and
amazing.
And we've piggybacked on the back of some of his contacts out there. But I was thinking about this 2-element array because you've got this 2-element 10-meter array giving you greater gain than a dipole, and the distance between the 2 elements, as you say, only 1/8 for wavelength. So we're talking about 4 foot apart, aren't we, between the two elements? So it's not massive, is it? The distance,
a little bit more than that, probably. It's 1.2 meters, 6 foot or something.
Yeah. But if you're saying 1/8 for wavelength at 10 meters is, 5 foot maybe, but it's not massive.
No.
And I reckon, Ken, you'd find a way of supporting that at the base of your trolley that you use there, with even on a piece of timber, would probably support those 2 poles. Would be very interesting. I'd be very interested to know what impact the ground, and of course the sea resistance is completely different anyway. But I was thinking of making a version of yours and just taking it up the hill and operating it from the ground. So two of the poles going up, fed with the phasing arrangement, and just seeing how that does on top of it.
On a trig point or something.
Yeah.
And especially if you've got a bit of noise coming from somewhere which is causing you problems, you could just rotate the thing and just null the noise. It would be could be quite, it could be a good, interesting thing.
Yeah, and you mentioned the 95 ohm feeder. It's not something that's commonly being used in amateur radio, is it? But the person I know who uses it and has done some work on it is the guy, what's his call sign? Is it FCI, G4FCI, who runs a little company called Spectrum Communications.
That's the one. They're the ones who make it. Yeah.
Yeah. He produces that, and I've read stuff that he's written about the wonderful noise cancellation you get from it, and if you want to use it at home, you're not going to suffer with problems of your TVI or audio breakthrough or whatever from this antenna because of the features of the 95 ohm feeder.
Yeah, it's obviously a great match to a quad because it's almost the same impedance, and he gets this stuff made specially for him, so it's quite good quality, really nice stuff. It's he's unfortunately the last batch I got from him is a white color. I don't know why he didn't realize that it wasn't colored, but basically it's quite, it's a log relationship, isn't it, with the twin feeder? So it's closer than you might think. So it's basically a speaker cable, but it's much better quality than speaker cable. But he sells it in 20-meter lengths, and I'm really pleased with it. It's works really well. So
yeah, G4CFY, yeah.
He sells it for HF. He doesn't really sell it for VHF, but I have sent him a copy of the article, so he's interested, and he said he might do the VHF spec at some point. But yeah, so I mean, you can never stop experimenting with antennas, right? How many antennas are there? How many variations? There must be hundreds.
That cable looks like shot firing cable that they use in the mines.
Oh, yeah. It does. I know what you mean, but yeah. Anyway, we'll see what the feedback is on that article. It's a little bit more. Anyway, I'm enjoying using it. It's really interesting. Of course, it's so light. So that's the other thing compared to coax. It's half or third of the weight.
Yeah.
Nick,
very. Yeah, go on. Who's got a question? Someone was going there. Go ahead. Yeah, go ahead.
Just a reminder that we had a talk a while back from Bob Bauer on his Antipodean adventure.
We did, yeah.
Now, if you remember, he was using verticals on the seashore.
He was, yeah.
And had some interesting stuff. And I think that's what you're really talking about.
Yes, and he's had a feature, hasn't he, for a couple of months in Radcom, basically of the talk he gave us.
That's right.
Explaining what he did there. And that was in my mind, Jonathan, when I was asking about putting those at the ground, because he was using phased vertical antennas. I mean, he was trying to work on 80 meters and use them on 80. For various reasons, it didn't quite work out as he hoped. But I think I've got a strong feeling that the antenna design that you've got here, this 2-element array, would work equally at ground level as it does at the point you've put it on the side of your house.
Yeah, I mean, interesting enough, the University of Sussex Club, they've got to double it for 40 meters, which is basically is a dipole, basically a horizontal dipole, and they've got 2 verticals. And the dipole routinely works better than the phase verticals, and they can't quite work out what's going on. And I wonder whether it's the earthing problem with the verticals, where you see with this, because they're half waves, you don't need any radials.
Yeah.
Where if you have quarter waves, you're going to have to probably have a really extensive. I mean, if you're in the sea, it's fine, but if you're not in the sea, up on the hill, there is an advantage of the half wave is you don't really need the radials. You see, and this thing is a 2-element beam without any radials. It's quite a compact. You don't have to worry about having all the radials, which I mean, radials are not a problem. They have to be put out and set up, but it's quite nice. Not especially if it's a movable thing. It's going to be difficult to move it with all the radials. So you've got there are some advantages to this. I don't know what the longevity of those telescopic rods is outside all the time. Obviously, you lot, if you're going out on the hills, you don't leave it outside. You go out, you use it, pack it up, and you come home. Well, mine are out there all the time. So I have a feeling I'm not sure how long they're going to last out there all the time, but yeah.
Up here in the Pennines, where some of us are, they're probably going to last a couple of weeks.
Yeah.
not even the day some days.
I mean, they are stainless steel, but they've got these copper shims, you see, and I'm wondering if you're going to get electrolytic electrochemical reaction between the copper and the steel or something, and eventually they're going to corrode away. But so
Well,
far,
I've
a year.
got
They've
up,
been all right for a year.
yeah, the hill behind me, Jonathan. I'm 600 feet above sea level. Hill behind me that I walk up to is probably another couple of 100 feet up.
Yeah.
And I use one of those telescopic whip antennas, and I've had to guy it but even with a guy, it still actually does bend in the wind. But at least it's not bending right over to the degree it's going to snap one of the junctions. But even on a day where you think there's not a large amount of wind, it really does move, and you need to do something to support it.
Yeah, that's right. It's interesting, actually, isn't it? I've tried various different masts. Once you get above about 10 meters, they all start whipping around if they're at this, if they're only supported at the base.
Yeah.
You know, it doesn't really matter how thick they are. There seems to always, you get to that point about 10, 12 meters where they start bending, you know, with virtually no weight at the top. And that's the problem I got here, is that I've got a 16-meter fiber mast, which is gorgeous. So it's 50 foot. And it's just supported at the bottom. So anything that goes on the top needs to be really light. And if it's windy, I can't put it up full height, of course. But sometimes I can get them really high, you know. Yeah.
And I was thinking you saying to Jeff, who lives in an apartment I know and has fantastic results on, puts everyone else to shame with any kind of garden space with the results you get there, Jeff. But I think you would probably struggle with two 15 and a half foot, 5 meter telescopic antennas. I think you'd have both a wind problem and struggle with that. But it occurred to me, and I know there are going to be some losses introduced as a result of that, of having quarter wave telescopic antennas and a coil underneath, and then phasing those two together as you've done in that, because it's a half a size, a quarter wave telescopic with a coil looks the same as far as the phasing arrangement's concerned as a half wave. So I reckon that would probably work in Jeff's location.
Yeah, no, I think you're right. And like I say, it's pretty broadband, so you could get away with having them shorter anyway. But yeah, that's right. And because of it's basically a twin feeder at the bottom for the phasing harness, it's never going to be any particular impedance. I mean, you're just feeding it at the middle and sharing the power. So you don't have to worry too much about the change in impedance by using a shorter one. I think it will work. Yeah, no, really interesting.
The distance apart might be different.
That's I don't know. Yeah, you probably want to keep to 8th wave, I guess.
I would start there and see what happened on the SWR, and then try moving it together and apart and seeing what difference it makes, really.
Yeah, no, exactly. Yeah, nice idea, I think.
Yeah, Adriana.
Yeah, I have a question concerning the 2-element array. You said you need a balanced tuner. Have I this covered right? Do you need a balanced tuner also for the 2-element array? And if you need a balanced tuner, is there a possibility to buy one, or do you have to build it? We are using, for example, my Hare G1EXG, and it has an inbuilt tuner which is quite doing a good job, or the tuner from Alecraft, but I don't know if they are balanced tuners.
You do need a proper balanced tuner, and some ATUs have a toroid in them to sort of make them like a balanced.
Yeah.
But it's better if you can. Let's go back to this if I can find it. Yeah, I mean, it does. It's really worth having a proper balanced feeder, and they're not very balanced ATU. They're not difficult to make. It's just getting the parts, isn't it? I've got a nice sort of junk box full of capacitors. But it's not a very difficult. It's basically 2 coils coupled together. So you've got I almost guesstimated these coils. There's a coil inside here which couples to that goes to the transceiver. To the radio. There's a coil that goes to this capacitor back to the ground. And this capacitor goes across the main coil. So this really tunes it. So basically you adjust this for best signal, and then you just adjust this to get best WR. And sometimes you have to do a little bit of both. And if for example, I was using it way off frequency and the impedance was a bit weird, I could try unplugging it to more the central of the taps. You know, if it's slightly lower impedance, I can try plugging it into here. But usually I just keep it like this, and I can tune. I can go all the way from 20 meters to 6 meters. Well, 20 meters to 10 meters on this capacitor, and I just sometimes have to vary this for the SWR. So it's a really beautiful, very simple, really system. Dual gang capacitor here, single here. This is connected to the box. This central connection is going to the box, so it's all electrically earthed. And it's a really, you design it for the capacitors, not for the look. So you basically put them wherever you can to keep everything short, especially at VHF. And I've got a little reduction jive here, but it's not necessary. You can just have knobs straight onto the capacitors, and it works really beautifully. And of course it acts as a little bit of a bandpass filter as well. So you've got an extra filter in there, which is always good for your receiver to have an extra bandpass filter in line. So no, so yes, if you're going to feed this antenna with the sorry, let's go back to here, because you don't have to use the balance feeder. So the article will tell you more, but let me just try and find the, so this on this page is, so you can either, I don't know if you can see my mouse here, but you can either feed the middle with the twin feeder, or you can have a little matching section where you tap on the coax and you have a shorting bar. And that works. So with just the coax going straight into this matching section, I could get a fairly good SWR over about 300 kilohertz, which is not that much of the 10-meter band. But then I put a 4-to-1 balun on and found a different tapping point, and I got about twice. But really, when I use the open wire feeder, everything is so much easier and simpler, and you know, it's a joy to use. It's so nice to use. There's no faffing. It really is really nice antenna, and it's just so easy to tune up, and I got very low noise. In fact, funny enough, I've been thinking about using it for the digital modes on very low power. There's so little noise that actually when I turn my computer on, I can hear the computer, you know, the noise level goes up because of my computer. So there's this irony that I want the digital modes on my computer, but the actual computer is producing noise. You know, it's this ridiculous situation. But so I've got to go and throw out rings on the computer leads. I think it's actually the monitor that's producing the noise. But so the noise level is really low on 10 meters with this antenna. It's gorgeous.
Yeah.
I'm right in the city in Brighton, so there's a lot of potential noise around me, you know.
There seems to be something for our array here. We are living in a serial house, and in the middle one, and we have a very small garden, and but it would be enough to put the 10-meter version on, I think.
Yeah.
So we have to think about it.
Yeah, I think that the plus points are you have this null, you know, this bidirectional pattern. So you have got quite a sharp null. So if you've got noise from one of your neighbors or from your own house that you can't turn off, you could in principle move it to null that noise, which is obviously nice. And if you build one with, you know, bamboo canes and wire, it's not going to cost you very much to make this antenna. You can just try it. And if it works, then you might go for the telescopic antennas, but go for bamboo canes to start with, and do it really cheaply, and see if it works for you, you know.
Thank you. Very, very interesting.
Thank you.
Thank you, Adrian. Yes, Ken.
Jonathan.
Yes.
Yes, it's wonderful. Thanks for that. You could, I suppose, run 300 ohm line all the way back to your transceiver and put a 4-to-1 balun in, which would avoid you having to look for little tuning capacitors and make coils, etc. If you use a proper balun, you won't get a lot of loss. Comment?
Well, I don't think the center of that end fire array is 300 ohms.
Mhm.
No, I don't think so. I think if you think the impedances of the ends of the dipoles are very high, and you're joining them up with the phasing, I think the center of the end fire is probably higher than 300 ohms, I should think. But the loss on the mismatch on open wire feeder, I've got like 30 foot of, or less than that, 25 foot of 300 ohm. That even if it's a 4-to-1 SWR or something, the losses are going to be quite small at 10
Yeah,
meters.
that's quite right.
Yeah,
I've got 87 meters,
yeah,
400 ohm line to a 10 meter, to a 15 meter square loop. And the coax loss is huge.
yeah,
But I mean, I run a 400 ohm line
yeah.
and a decent Ganella balun, being careful about the balance.
Yeah.
There's a lot of dud ones about.
Yeah.
Assuming you get a good one, then that would avoid Adrian having to worry about making another box with a few little things in.
Yeah, but it's worth it because it's fun.
Once she's established it's worth it, then she can make a little box.
Yeah, no. Oh, I see. What? Yeah. So what you could do, you could run. Yeah, you could run the 300 ohm to the 4-to-1, and then have that going into your ATU, I guess.
Yeah.
Yeah, that's a good idea. I like that idea.
Might be.
But that's effectively what's available commercially.
Yeah.
So I bought from MFJ. I know they're not producing them anymore, but I bought one of their portable ATUs.
Yeah.
It will take up to 100 watts. It's only very small. It's about just 10 centimeters in length or something. Quite a slim little ATU, and that's got a small balun built inside it. So when you feed it with 300 ohm feeder, it goes through that balun. But you could do exactly what Ken has said, is just make your own, either buy a 4-to-1 balun and insert your 300 ohm feeder into one side of that 4-to-1 balun and take the coax into the back of your radio or ATU in your shack, or make your own 4-to-1 balun. As we know, our good friend Rick, DJ0IP, on his website has got absolutely superb build instructions for building a decent Guanella 4-to-1 balun with the exact ferrite and the right materials to use with it. And as people remember from Rick's talks, Rick, I don't know if you've come across Rick, Jonathan, DJ0IP, if you've never seen his website, it is just jam-packed with information. He was the technical director on the board when they first set Spiderbeam up in the US, and now lives out in Germany, and he still acts as their kind of technical consultant. He's just told me the other day he's rewriting their manual at the moment for the Spiderbeam antenna. But he designed, there's a couple of commercial versions sold of very lightweight off-center fed dipoles made with DXY, very thin but very strong, very good tensile strength. And these are made as off-center fed dipoles to fit an inverted V running from 40 through to 10 meters. Well, Rick designed those and designed the balun inside, and he is fanatical about having a hybrid balun on an unbalanced antenna. So you've got a 4-to-1 if you need a 4-to-1, and then a 1-to-1 balun to cut out the current mode that otherwise would be flowing down the coax. But I would if I was Adriana and I'm thinking I'm not going to use this that often, rather than build a separate ATU, I'd put a 4-to-1 balun in there.
And it needs to be a current balun.
Yeah, exactly. Yeah. Needs to be a proper Guanella. Needs to be a Guanella banner, doesn't it?
It's only got one toroid in. It's not a current balun.
Yeah.
If you get a Guanella, a current balun, it will also give you a choke in it as well, which is helpful. But it will have two toroids in.
Yeah, this might be a good solution, I think. Thank you very much.
Yeah, it's a really nice comment. I might try that. What was it? DJ9?
DJ0IP.
Okay. Yeah, no, I might have a go at.
He's got two websites, and he's one of those people, Jonathan. He came and gave us a talk a couple of years ago, in 2 or 3 years ago, in Denby Dale, when we were part of Denby Dale Club, and I spent a year working with him to give his what turned out to be a 2-part talk. But it took a year because he wants to give us a 12-part talk to start with on on antenna designs and balance. But he's got it all up on the website, and I know from talking to him out in his house out in Germany that he just spends hours and hours and hours outside putting these antennas up, doing measurements, changing the lengths, doing more measurements, doing all those measurements on every band. He's absolute. I mean, he just spends days and days of his time doing this. But you know, the information he's made available to the amateur radio community is massive.
Yeah, massive. Yeah, fantastic archive, basically.
It's you'll be amazed when you look at it. He's got 2 websites. You'll and also the talks he gave at Denby Dale, the videos are available from links on his website as well. So anyway, yeah, thank you. Right, anyone else got any questions to Jonathan before we call it tonight with Jonathan? Let him go. I promised him about an hour and a half, and we've gone for a bit longer. But
that's all right.
anyone else got a final? Yeah, go on, Phil. Go on.
Yeah. Hi, can you hear me all right?
Yeah.
Hi, Jonathan. Thanks. Fascinating talk tonight. I do quite a bit on 40 and 80 using phased verticals. I've got 2 of these 60-foot spider poles for 80 and 2 30-footers for 40. And I'm just thinking, I'm just using a single delay line, which, you know, works very well, actually. But I haven't gone the full square route, and I've kept things as simple as possible. But I'm just thinking with 40 meters, you know, your 10-meter sort of version, scaling that up, really, you know, whether it could get a bit more out of things. I've got 4 elevated radials on each of the 40-meter verticals. And, you know, obviously just thinking along the lines, because I'm going to replace the fiberglass poles with aluminium tubing when the weather's a bit better, and make the thing a bit more rigid, a bit more permanent. Am I right with this beam of yours? You've got it sort of. Hang on a minute. Let me turn that down. Sorry. You've got it mounted to the house, but you are steering it, aren't you? Effectively, getting it. You know, the direction you are getting. Yeah.
I'm choosing to leave it east-west because my neighbour's to the south. So I'm trying to make sure I don't put too much power in his direction.
Through the hi-fi and that,
and because it's a nightmare. I have tried all the obvious things, putting toroids on the speakers and putting toroids on the inputs. But part of the problem is it's 1980s equipment, right? And I don't, you know, it's going to go wrong at some point, and I don't want him to blame me because I fiddled with his equipment that it goes wrong, you know. So there's an element. I initially did the obvious things of putting ferrites, but as soon as I realized that that wasn't going to solve the problem, I thought, well, you know, this is old equipment, and I think I'm just going to find other ways of getting around this. There's no problem VHF, it's just HF that comes through his setup, and there's probably a solution, but he didn't really want me to touch his equipment. So anyway, sorry, that's going back. I think so I don't actually steer it much, but you could do, and you only have to steer it 90 degrees because it's a bi-directional thing. If you feed it at one end, then you've got basically an HB9 CV, so you've got much more directivity and a better front to back ratio rather than the side. So you could, by a clever arrangement with relays, probably have a steerable antenna. You don't have to move. You know, you could switch to either side and a bi-directional. You could probably do that with an open wire system and have could be quite nice antenna without any radials.
Yes. Well, this is trying to make things a bit simpler. Yeah.
I mean, on 40 meters, it's not so bad, right? On 80, it's a big antenna, right? Each one's maybe 40 meters high, but on 40 meters, they're 20-meter high, and you could probably get away with not quite that height if you know, because like I say, it's quite broadband. I can use my 10-meter one on 20. It doesn't work very well, but it seems to work quite well on 15. So you know, none of these things. If you have a balanced ATU, I think you can get away with quite a variation in size, and you could try different things out.
Yes, because these I'm using obviously quarter waves on 80 and 40, obviously for the size, yes. Yeah, food for thought anyway.
But
Yeah.
as Nick said, if you can put some coils in there and electrically make it look like half waves,
yeah,
I'm not sure. I'll have to think about that, whether that will work. I mean, it should do, shouldn't it? But yeah, we'd have to model that a bit. And ideally, of course, you want half wave elements, really.
yeah. Okay, thank you.
I mean, the nice thing is it's not an expensive antenna to play with, you see. If you've got a balanced ATU, you can make all this out of wire and just try it out, you know, with bamboo canes or something. And, you know, you could build this for very little money and just see if it works in your setup, really, you know. And so it's a really, really nice thing.
Yeah, very good. Thanks.
I like a lot of people, to me, half the thing is the experimenting and the trying different things. Some people want a perfect station set up, ready to go, and they don't want to play too much. But others of us just love the fiddling around and trying different things. And you know.
Yeah, and I think what you've introduced to people, Jonathan, is within most people's capability of repeating and building. And as you say, if you're doing it just with wire and canes, you can do it very cheaply and you know, see how it works. And I think for me as a radio amateur nowadays, and I think a number of us feel the same, playing around and experimenting with different types of aerials is the good bit of the hobby. You know, we're unlikely. I don't think there's many people in the room are capable of building, you know, a transceiver of the quality of the, you know, the ICOM or YC rigs that are available in the last 20 years that we could build ourselves that would work as well as these do. But we could build antennas that work as well as any commercially built one.
Yeah, I mean, I think you could probably. I've certainly still build receivers, but they're single band receivers. You know, I'll just build a top band direct conversion receiver, and it works really well. But I'm not going to build something that goes from top band to 77s like the 817, am I? No way. You can't really do that. But you can certainly build single band things, I think, still. Yeah. But yeah, the aerials are, like you say, for a few pounds, you produce something that's basically just as good as it's not going to be as good as a £400 aerial in terms of standing up to the weather and stuff and all the other stuff, but you can try things out, and if it doesn't work in your location, you can ascertain that, can't you, and try something else. Yeah, which is always fun.
Okay, well, anyone got a final call? Any last minute questions, observations anyone wants to make? Yeah, Roger, go ahead.
I just say, Jonathan, finally, I don't think anybody's commented on it. We're all very admiring of your man cave. It's very tidy. Thank you.
It's actually a big room, but you wouldn't know it. My wife comes in here and she goes, "There's yet more of the room has disappeared." To I've actually, the way I mean, you know, with papers, books are okay because they stack on shelves, but papers are the thing that I really struggle with, because almost all the papers I've got I've printed out because I want to keep and read. So what do you do with them? So I've started, you know, normal box files take up a lot of space, so I've started using these smaller box files, these plastic ones. And so, because a lot of the box files I've got with papers are half full, you know, and so you end up using up all your space and everything's half full. So I've tried to go to neater storage solutions, so you still fill the room, but you've got a bit more in there.
Well, it looks fabulous anyway, so thank you.
Thank you. It is a very lovely space. I'm very lucky.
Yeah, we're all jealous of your detail. I've got boxes and boxes and boxes, but I'm afraid I seem to have got them muddled up. And every year I promise, you know, when we've got bad weather for, you know, several weeks with rain and terrible weather outside, I'm going to get them all out. And for some reason, something else comes along and I put the job off.
I started writing an article for Radcom on storage, but I thought it was so boring that no one would be interested. But, you know, I have got a lot of storage here and different techniques, different size boxes for different storage. Yeah. Yeah. I mean, is that something that you think people would be interested in, or is it too boring or is it something you want to read?
I'd be interested, very interested.
Yeah, I think it is. That would make a superb article, or superb, and a superb presentation as well.
Yeah, certainly crying out for it here. They're trying to.
For people who can't sleep very well, you know, I could write something.
I've got a final question.
Yes.
For you, Jonathan, if I may. Right. very interesting this, and this might be something interesting for Phil, because I know Phil's into the vertical antennas as well. Have you experimented with quarter waves near the ground, either steerable using multi-verticals as against your half wave, which is approximately a half wave high? Because I know the half wave will present a lower angle takeoff than a quarter wave.
Yeah.
And I'm wondering, when it's up at about, well, for 10 meters, if it's up at, what is it, 30 feet, which I think yours is not far off, I bet.
The top of it, yeah.
Is it going to give such a sharp angle of radiation that it's going to cause RF-wise 100 watts, 200 watts, going to break into your neighbour's hi-fi, no matter what? And if it was at ground level as a quarter wave or ground level as a half wave, I wonder, because the old saying is a half wave should be a half wave above ground.
Yeah. Well, I don't know the answer to that question. I mean, I know I've tried so many aerials and they all come through on his setup because, you know, he's so physically, it's like being in a flat, right? You know, they're so close. His equipment is only 20 foot away at the most, 15 foot, you know, it's not very far. So that's why I've moved it to the side of the house as well, to get a bit further away. And there's a bit more concrete to go through to his house. But no, I haven't basically answered. To answer your question, I wish I had more space, because I'd love to build a 4-square. I mean, you know, I love 80 meters. It's the band I love to listen on with homemade receivers. And, you know, the guys are using 4 squares and things. And I'm so jealous, because you're out in the middle of nowhere with a 4-square. You know, these guys are working doing amazing things with those aerials. And I'm very, very jealous. And I'm basically using a loop for receiving, a Wellbrook loop and an LZ1AQ loop, and it works pretty well, but it's not the same. But I'd love to have a phased array. But and I had thought a bit about building a 2-meter version and just playing with that, a 4-square for 2 meters. I think that's what the police have on the car by the looks of it. I don't know whether you've seen the police cars, but they seem to have 4 little aerials in a square, and it looks like it's a 4-square. So it's probably some clever thing that's continually switching, getting the best signal, I guess.
I think it's a Doppler direction finder.
Maybe. Yeah. Well, that would make sense. It probably is a 4-square. Yeah. So I haven't got the space, but I'd love to play with those things more. But yeah, it's just space.
I see what you're doing with putting 2 elements up, so you're not firing east. Sorry, you are firing east and west.
Yeah.
But it's inducing direction into it, so that north and south has got the weaker signal.
Yeah.
So I'm just thinking, if you have them at ground level, or near ground level, will it still cause interference? Maybe not. Maybe not.
Maybe not. Yeah. Sorry.
Food for thought, that one.
Yeah, no, definitely. I have got loads of terraces around me, so my inclination was to mount as high as possible as in the air, you know. Otherwise I'm sort of beaming into a lot of concrete. But yeah, I think you're right that it's worth traveling with this antenna and trying different places, really.
Well, tomorrow I intend putting up a half-wave end fed, which will cover 40 meters.
Yeah.
Now it's not 60 foot high.
Yeah.
It's about 28 foot high. It's obviously linear loaded at the top.
Yeah.
And my aim is to get it as high as possible on the tower.
Yeah.
Well away from houses, because I know if I brought it down to something lower down, I just think it could cause more problems than what it's been worth to put it up.
No, that's right.
I've never had a problem with quarter waves. So it's interesting, this one.
Well, in the chat a bit earlier, Gavin, who came in the discussion there, said he just bought 6 of those telescopic whips from China for £60, including postage and duty. So I can imagine he's going to be off building variations of what you talked about tonight, Jonathan. Got no doubt of it at all. Well, look, can I? Yeah, go on, Robin. Yeah, go on.
Yeah, I've got to disappear, but can I say thank you to Jonathan? Well, I used to talk about aerials as a boy. Yeah, my QTH, I'm very lucky. I have sheep and cows, and I do have neighbours, but they're nowhere near. But I used to speak to a radio ham. He was down in Ayrshire,
yeah,
when I went to agricultural college, and he was elderly. He was housebound, and his radio was his thing. I used to speak to him quite often, and he had the unfortunate. Well, he didn't have the unfortunate thing, but a nearby church put in a new PA system, and he was broad Ayrshire. Very few people could understand really what he was saying, and one of his friends came round to say that every Sunday, while he was housebound, while he was chatting to people, he was coming over loud and clear on the church PA system. So there had to be a wee bit of help made there. But thanks for your talk. I kind of feel that a lot of the, new hams, people who sort of start out, I think they're a bit of, I don't know, are they afraid, or maybe they just don't think that they could build antennas. But as you say, bits of wire and canes and whatever, and experiment. And I think it's a really good grounding for people, if they can, to learn not everything, but a bit about antennas, because it makes such a difference. It's no good pumping out hundreds of watts if it ain't going anywhere. So yeah, thank you very much. The problem, I don't have a problem, but because of where my QTH is, I can't make anything lightweight. I make all my own stuff. It's extremely heavyweight.
Yeah.
So it stays up, because I don't go out and in taking things up and down. They're up and they stay up.
Yeah.
Winter storms and all. But thank you for very interesting talk. And I'll say good night to everybody. And we'll catch you all again soon. And
thank you.
Take care. 73, everyone.
Cheers, 73, Robin.
Bye.
73.
Yeah, Robin's up at John O'Groats, by the way, Jonathan. So...
Oh, wow. Lucky man. Nick, you're recording this. Are you putting this on YouTube, you said?
I am, yeah. Yeah, I'll send you the link.
So anyone can watch that, can't they?
Yeah.
Okay.
Yeah, I'll send you the link, and it's available to everyone. Well, look, before you disappear and we stop recording, I'm going to say, on behalf of the club, a really big thank you for tonight's talk. It was really interesting.
Thank you.
I can see from the reaction in the room, lots of people have got their thinking caps on about what can I do with some of those ideas that he was giving us tonight, and they're nodding to me now. So I know it's inspired a few people, and they're going to come back to this, I'm quite sure, at a later date and say, I built one of Jonathan's antennas, and this is the result of it.
I think it's Fred Judd's antenna, actually, but
it was Fred Judd, yeah, in that lovely book, the Practical Wireless, that little booklet that Practical Wireless produced many years ago. So can we show our appreciation to Jonathan in a normal way? Thank you, Jonathan.
Thank you. Thank you for inviting me.
That's okay, and hopefully we'll see you again another time. So 73s to you, Jonathan, and 73s to all those watching us on YouTube and watching the video in the end. And hope you enjoyed our meeting tonight.